Hello students, a very warm welcome to JEE English Unacademy, India's leading and largest JEE test preparation platform. And today we are on the fourth session of your Magnetism, where we are discussing your 10 years previous year questions. And you have already completed your majority part of your 2020 previous year questions of your JEE Mains. And today we'll be diving into your 2019. But let me remind you that in your 2020 there is two parts, so we have a little bit more left in it, and you should be also taking care of that part. So that's going to be more of a theoretical part. We would not be discussing exclusively about that part, and that's not either that important. I mean, that's also important, but that is not either that important. So we'll be focusing on the most important concepts and aspects, and you don't have to worry about it if you don't know the concepts. We'll be revising these concepts in this session. So stay tuned. It's going to be a very interesting session. And that being said, I'm Muralidharan Gopalakrishnan. I completed my MS in Electrical Engineering from one of the top-ranking American university. I'm also an IIT who completed BTech from IIT Guwahati. I have 4+ years of experience preparing students for IIT JEE and other competitive exams, and I filed 25 patent applications on state-of-the-art technology in India, US, and Canada. And that being said, students, if you're looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription any day. Why do we say that? Because we have the best educators across the nation. In fact, the authors of your books like DC Pandit, DC Gupta sir are present on our platform. You can attend daily live interactive classes with these best educators on a very interactive platform with polls and leaderboards. And that way your learning becomes interesting. Not only that, we will provide also lots and lots of test series set by the best educators, post which you will be also getting access to good analysis based on which you can improve upon your overall performance. And not only that, you will also get access to one of the major components or the most important part of your JEE preparation, that is going to be a live doubt clearing session. You will get access to lots and lots of live doubt clearing session. In fact, every course, every program is going to have live doubt clearing session as its fourth session. So here you don't have to worry about the planning. We take care of the planning. We have dedicated courses, like structured courses that are taken in a very systematic manner, so that you don't have to worry about the planning, and we do it on our end. And not only that, Unacademy subscription not only provides structured courses with the best in class educators, but we also provide you unlimited access throughout the period, so you don't have any batch restrictions, etc. on Unacademy subscription platform. And how do you avail an Academy subscription? You can do it from app-based or web-based version. Do log in, click on the left-hand top corner extension bar, select plus, select IIT JEE as your goal, and hit on this get subscription button. And post that, you'll be redirected to the payment page and program selection. And there, students, probably you know what you should be going for. But if you are a 2021 aspirant, like a 6-month program is for you, which is going to cost you near about 25,250. And if you are a 2022 aspirant, so you can be also 2021 aspirant but have a plan to drop, then definitely do go for a 12-month program. Or you could be in 11th class and you would have completed 30-40% of your syllabus. You want to go for a 12-month subscription, which is going to cost you less than 35,000, 34,650. And students who should be going for 24-month program, 2023 aspirants should be going for 24-month program, because 2 years is good enough to build your it's the kind of time that you require to build the fundamentals, etc. And within that 2 years you'll be able to do it very efficiently. And how much is a 24-month program going to cost you? Near about 50,400. That's going to be near about 25,000 for 1 year, less than 70 rupees a day. And as I told you in the beginning, we have started dedicated courses, even some by some popular coaching institutes of India like Vibrant Educators, and also Bansal Class Educators on our platform. And not only that, we have some of the best educator teams and IIT and NIT alumni who are also taking classes, and as you know, some authors of the book. So we are having dedicated batches depending upon your target and your aspiration on an Academy subscription platform. And this is about a plus subscription. We have something beyond plus subscription known as iconic subscription. So what is this iconic subscription? Iconic subscription is one where you don't only get access to all the features of plus, but along with that, you will be also getting access to one-on-one mentoring session, personal coaching from IIT and NIT alumni who are educators on an Academy subscription platform. So they will be taking you through this journey in a very efficient way. So think about it, they have previously gone through this journey. They know the ups and downs. They'll be guiding you with the necessary motivation that you need for this journey. And not only that, they know the ins and out. They will be guiding you the strategies, and based on your preparedness you can get the personal guidance and personal advice from them on Iconic subscription. And of course, if you can afford Iconic subscription, it's going to be one of the best things for your JEE preparation. And a 6-month program is going to cost you only 34,200, and a 12-month program is going to cost you 58,500, and a 24-month program is going to cost you 90,000 for 2 years. That comes down to like 45,000 per year. So per year cost is like 45,000. And make sure you apply Murli Live code, be it you go for like plus Iconic 6 months, 12 months, 24 months subscription, so that you can get the maximum discount on your subscription purchase. And not only that, you can also apply Murli Live code on combo subscription. So what is this combo subscription? We have recently introduced something known as combo subscription, where you can get access to both CBSE board coaching and IIT JEE coaching at one place at an economical price with the best educators across the nation. And this pricing can go as low as less than 90 rupees a day for 2-year subscription, and less than 120 rupees a day for 1-year subscription. And make sure you apply Murli Live code, be it you go for even combo subscription. And we do also have different combinations of combo subscription, and we'll discuss that at the end of this. And that being said, let's jump into the first problem, and it's a very interesting problem, students. Okay, let's see what is being asked in the problem. We have a small bar magnet. So this magnet, what kind of magnet is this? I think it's a bar magnet, so a permanent magnet, and with its axis at 30 degrees is an external field of how much? 0.06 Tesla, and it experiences a torque of how much? 0.018 Newton meter. Read the question carefully, don't make any mistake here. It's quite easy to make mistake in such easy questions. Work required, or minimum work required to rotate it from stable to unstable position is how much? Okay, so it's at a stable position, you need to rotate it to an unstable position. You will be doing the work. Okay, two different informations. I mean, like a question is asked based on some given information. That information is going to give you some necessary thing. Let's understand how to solve this question. A small bar magnet is placed at 30 degrees. Some theta is 30 degrees between whom and whom? Magnetic moment and your field. And field value is given to you, and even the torque value is given to you. So what do you need to find? You need to find exactly. Then it's the difference between the potential energy of that stable configuration and unstable configuration. That's it. That's all it is. So it's going to be mb sine theta, and how much is torque? Torque is 0.018. Let's write it down as 1.8 into 10 to the power minus 2, and we have m, and what is the value of b? 6 into 10 to the power minus 2. Wait, this 18 into 10 to the power minus 3. And how much is sine of how much? 30 degrees, which is like half, right? Okay, then mb or m, magnetic moment of that magnet, is going to be how much? Like 1.8 into 10 to the power minus 2 divided by 6 into 10 to the power minus 2 into that of sine 30 degrees, which is nothing but half. 10 to the minus 2, 10 to the power minus 2, and this comes out to be 0.3, and magnetic moment comes out to be how much? Something like 0.6. Okay, is that correct? Yes. Ampere meter square. Okay, then we know the magnetic moment. Then what do we need to know? Very simple. Okay, it's all in SI units. Just to definitely verify whether it's in SI units. You are getting it in SI units, else things are going to go wrong. Be very cautious about it. So what is the stable position? Stable position is when this and field. Moment and field vector. You can think about it, moment and field vector having how much angle between them? 0 degrees. Okay. Why? Minus mb cos theta. M dot b. Minus m dot b. That's it. Just try to grasp it right away, students. If you haven't done these concepts earlier, it's not at all a problem, but you need to focus and try to grasp it. You will get it. And then similarly, if you know this, you know what is the unstable position. Unstable position is that going to be like 90 degrees. Is that it? Of course no. It's not going to be 90 degrees. It's going to be 180 degrees. Okay, sorry. Yeah, this is unstable position. It's going to be 180 degrees. Right? That is where your, it has maximum energy. Unstable position, stable position, minimum energy. Why? Because you calculate the energy, it's going to be how much? Like it's going to be minus m dot of b. Okay, basically mb minus, don't forget the minus sign, else the meaning would change. This is going to be u. Now what is the work done? Difference in potential energy. That's it. That's all you need to know. It's a very simple problem. So work done is how much? U final minus U initial. Yes. Correct, delta U. How much is this going to be? MB cos 180 degrees minus MB cos 180 degrees minus of MB, my goodness, should have been cos, right? M dot B. Isn't it? Was written as, just to correct it. Of course, you know this dot product yields cos. Okay. And this is going to be how much? Minus of minus MB cos 0 degrees. Okay. Minus of minus MB cos 0 degrees. Okay. Write it down once more. So minus of minus MB cos 0 degrees. Cos 0 degrees 1, right? And cos 180 degrees minus 1. So it's going to be MB, basically MB, and the other one is also going to be MB. So it's going to be how much work done is 2 magnitude of magnetic moment multiplied with field. That's what we need to do. That is it. So work done is how much? Work done is equal to delta U is equal to 2m into b, which is going to be how much? 2 into, we just derived the value of magnetic moment, but we know the value of your field is going to be 0.0, right? Okay, and then yeah, 0.6, is that it? Magnetic moment. End of the story. It's a very simple story. So what do we get? We get something like 72. Work done is how much? 72, 36 into 2, 72 into 10 to the power minus 3. How much? End of. Okay. 7.2 into 10 to the power minus. Simple question. Let's move on to the next one. This is also again a very important concept, so do focus on this. So given to you a paramag, that's it. That's the end of the story. There's nothing more in the story. It's a very simple story. Okay. So paramagnetic sample shows a net magnetization of 6 ampere per meter when it is placed in an external magnetic field of 0.4 Tesla at a temperature of 4 Kelvin. Okay, it's a good thing, here the temperature is given in terms of Kelvin. Else do convert the Kelvin into whatever we are going to do, convert the Kelvin into Celsius. We are always dealing with Kelvin, not in Celsius. If it is given in terms of degree Celsius, do convert it into Kelvin. So when the sample is placed in an external field of 0.3 Tesla, then the magnetization will be. It's a very simple problem, damn simple problem. Okay, so your magnetization is proportional to B by T. Okay, keep it as small m because we are already using capital M. Magnetization is proportional to B by T. So M1 by M2 should be how much? B1 by B2 into that of T2 by T1, right? That's how it works. Now what do we have? Yeah, every single data that we need actually. Okay. Given to us M1. Okay, let's write down that thing. M1 is how much? 6 ampere per meter. Rest will be directly substitute. Okay. So M1, that is like 6 ampere per meter divided by M2 is equal to B1. B1 is how much? 0.4 Tesla divided by T1, which was like 4 Kelvin. And then we have B2, which is like 0.3 into that of how much? 24 Kelvin. Okay. Here 10 goes. You have 4 and 3. 4 goes, and you have this 3. Here this is 4 times. So we have something like 3 by 4. Magnetization in the second case is going to be how much? 3. End of the story. We're going to get into a very interesting problem, so just stay focused. Okay, this is also the easy one. I don't mean this problem. After this, we are going to get into a really interesting problem, and you should stay focused on the next. This is a very simple. Most of you should be knowing how to do this. Definitely do try it out. Just get started. Photon with kinetic energy, it's actually proton. I guess it cannot be photon because photons don't have charges, so it should have proton. So proton with kinetic energy of 1 milli electron volt moves from south to north. It gets an acceleration of 10 to the power 12 meters per second square by an applied magnetic field west to east. Then what should be the value of magnetic field such that it is able to get the 10 to the power 12 meters per second square acceleration? Velocity and field are perpendicular, right? Moving from south to north, field is from west to east. We know the first thing. Okay, let's get into this problem. Very simple problem. Electron volt is how much? 1.6 into 10 to the power 19. So 1 mega electron volt is how much? 1.6 into 10 to the power minus 19 into 10 to the power 6. So basically 1.6 into 10 to the power minus 13 joules. Okay. Now, how much is going to be the velocity of this proton? Okay. Kinetic energy is nothing but a very simple problem. It's a very direct problem. Problems can be this easy, in your magnetism, given that you understand some of the, not always, it's not easy, I wouldn't. This is how much? 1.6 into 10 to the power minus 13. We need to substitute the mass. Mass is going to be how much? Mass is going to be 1.6 into 10 to the power minus 27 into V square is equal to 1.6 into 10 to the power minus 30. 1.6 gets cancelled out, 10 to the power minus 13 goes off, and you'll be getting something like 10 to the power minus 14. So V should be like, so it's going to be 2 into 10 to the power plus 14, and ultimately when you work it out, you will get this to be root 2 into 10 to the power 7 meters per second. Okay, if you calculate it, it will come out to be root 2 into 10 to the power 7. Right? That's it. Is that fine? Yes. Now, what do we have? We have some magnetic field value that we need to find. Now let's understand this thing. Okay, it's a very interesting problem, definitely. So it's moving from where to where? It's moving from south to north. So let's say you have a proton, and how is it moving? From south to, very important. Why this is important? Because direction matters a lot. And how does your magnetic field, applied magnetic field is your magnetic field? So it's moving like this. Let's first of all control. Moving like this with some root 2 into 10 to the power 7 meters per second. And what is the value of magnetic field? Magnetic field value is something that we need to find out, but we know it is getting accelerated by how much? 10 to the power 12 meters per second. They are perpendicular. Okay, so can we say something like this? Force on this, it's basically perpendicular, right? Can we directly write it down as QVB instead of writing down QV cross B, again QVB, like sine 90? It's basically Q, saying that this has some charge Q. What is the charge Q going to be ultimately? So this guy having, and this is equal to how much? Mass into acceleration. Okay, we know the value of velocity, we know the value of mass, we know the value of charge. Value of mass is given to us. Okay, we could have kept it as it is to even solve it somewhat quickly in our case, but we ultimately calculate, but still it's easier, like it's all 1.6, they would get cancelled out very easily. So now what do we have? We have to substitute the value and get them. So let's do the calculation. So we have QVB is equal to M into A, where mass is how much? 1.6 into 10 to the power minus 27 kg into acceleration. And what is your Q? 1.6 into 10 to the power minus 19, right, coulombs. And what about your velocity? We just calculated it. We need a little bit more space. Okay. Even acceleration value is given to us. Also substitute. Don't think another line to do this. So acceleration value is how much? 10 to the power 12 meters per second square, all in SI units. Okay. And what is the value of charge? 1.6 into 10 to the power minus 9. Actually, it's important in this case that you note it's all SI units, because often it happens that it appears to be something else, but it will turn out to be that easy question that you. Okay, and into B, 1.6, 1.6, and then you have 10 to the power minus 27, and you have like 10 to the power minus how much is left? 8, and here we go 10 to the power 7, 10 to the power 12, 10 to the power 5, and that would be like 10 to the power minus 3. Okay, that's fine. 10 to the power 8, 10 to the power 4, 10 to the power 4, right? You'll have 4, 3, we'll have 10 to the power minus. And B is going to be how much? 1 by root 2 into 10 to the power minus 3 Tesla. Okay, now comes the thing. Now comes what thing? Just multiply with root 2 on the numerator and denominator. Doing this to not do 1 divided by 1.414, because that is not convenient to us. What we are doing is, if we do this, it's more convenient. So we'll be getting something like root 2 divided by 2 into 10 to the power minus 3 Tesla. How much is root 2, students? Root 2 is 1.414 and all. Okay, let's later on write down the 1.414 etc. So it will be like 0.707. 1.4 divided by 2 into 10 to the power minus 3. This should be how much? Something like point how much? 7 into 10 to the power minus 3. Okay, so field should be 7 into 10 to the power minus 4 Tesla. End of the story. Easy, simple. So milli Tesla is given to you. It should be 0.7. So we have 7 into 10 to the power minus 4, right? Milli Tesla, it's going to be 0.7 milli Tesla, like 0.71 milli Tesla. Okay, this value is very nearby, so that's the reason. So what did we have? We had our field that we found out to be magnitude of how much? 7 into 10 to the power minus 4 Tesla. So this is how much? 7 into 10 to the power minus 1 milli Tesla. Comes out to be how much? 0.7 milli. Okay, now this is that interesting. Okay, a very interesting problem. Very this I think was also asked in your JEE Advanced, repetition probability. So okay. So now given to you a very long wire ABD MNC is shown in the figure. Okay. Now what is being said? And they are carrying current I. AB and BC are at right angle. Okay, that is also given to you. And at D it forms a circular loop. You know that as well. Okay. AB and BC are perpendicular. What is that loop that we are talking about? ABD, and then we have MNCDC. So this is very important in this question. A, quickly, it's A is very long, A, and then what is happening? B, we have reached B from A. A is at some point other than that, and then what do we have? We have something like D, and then it goes to M, and then it comes to N, and then it goes to D, and then it goes to C, which is the wire carrying part. Other than this, this part does not carry any current. Okay, and what is given to us? AB and BC are tangential to the loop. The magnetic. You already noticed it, amazing. But how many loops, or how many, not loops, I would say, how many, like elements are there which are going to create magnetic field? There are actually how many elements that are going to create the magnetic field? 3 elements, isn't it? One is this wire, other is the wire perpendicular to this, and the third one is the loop. Okay. And where are we supposed to find out? Magnetic field at the center of this. Okay. Let's get started. Just focus on this. So this part is not applicable. So let me do a thing. This is where you have to put in your focus, otherwise it's a very easy. This part does not exist. What do we have? We have this point to this point basically, and this would be how much angle? Carefully. It's a simple one, but this is a very nice problem. Okay, now this is how much angle? I think you know what, you can find out this angle. Basically this is also R, this is also R, this should be 45 degrees. Okay, right, this should be 45 degrees. Hope this is now. This you can actually think about AB actually as a long wire like ABN up until here, where NB is not present. Okay, where NB is not present. If you understand this, rest is easy. There is a little bit more game, that is like your direction game, how the magnetic field is going. Otherwise it's a very easy. So if at all I have a wire like this, a current carrying wire. Okay, let's assess the direction later. We are just talking about magnitude. Okay, we're just discussing about magnitude. It's a long wire, right? This angle is going to be approximately how much? Like very large. And we know one thing. This is the only thing that you need to understand perfectly. If you understand it, it's not at all a big deal. Any such question, you'll be able to do it. So let's say, you know what, for now, this is something like theta. And you know, this is how much? This is long, I mean like infinitely long or something. So this is going to be 90 degrees. Think about it. I'm going to project and this will keep increasing. This angle will become how much? So let's say I have a point here and I'm supposed to, you know, like find out angle between this point and this end, right? Let's say this end is extending. What happens? this angle will ultimately become 90. Okay, very good, you know that. Now comes the thing. Okay, now this is the most important part. What I am saying is, what we should be understanding is, this part does not exist. If I have to calculate field at this point, this part does not exist. But we can consider one such part which is carrying some current, the same current I, and say that this part does not exist. So I'll take it as something like creating negative magnetic field, but rather this one as creating some positive magnetic field, which is not true, but which will work because we are subtracting the magnitude of the magnetic field that we should be otherwise be subtracting. Let me come to this. What I mean is, let's do a thing. Let's calculate as if this is infinitely long wire and it has started here and it has ended somewhere over here. Okay, just a moment. Has ended somewhere over here. Okay, but we can take a overlapping component. Overlapping component is this thing in purple, which does not exist. Okay, which actually does not exist. So this to be like creating a negative field of this. Okay, what is, let me come to this, what is the field at this point P due to this blue color one? Blue color one, as such, just let me quickly jot it down. If you know this, if there are, this wire has two angles, let's say, and there is also another angle, like, you know, let's call this as theta1 and this as theta2. Just to quickly remind you, just the black is just to remind you, so don't, if you already know it, it's fine. Field is going to be mu naught by 4 pi into I divided by the distance between this point and this point. In this case, it's basically r. Is that it? So ear to ear, how much is the distance? R. You're assuming up until here, if you understood, this is the purple part. And blue part is that one on the bottom. Okay, so that is going to be what in this case? In this case, it is going to be I divided by distance r into that of sine of theta 1 plus of sine of theta 2. Exactly this would look like. Okay. Is sine of 1 plus sine of theta. Okay, now we understood this part, rest is easy. One more thing I would like you to understand is the direction, otherwise there is nothing. How much rank is needed to get into NITs, Mohan? I believe you should be getting anywhere around 20,000 to 30,000 should be good enough. 35,000 you get it, but I think 20 to 30 should be the cutoff. Like, you should be giving some priority to branch if you're not oriented towards science. What is theta 1 in this case? Theta 1 for both is going to be 0 degrees. I hope I answered your question. Okay, plus of how much? Sine of theta 2 for the blue one, right, is how much? Sine 90. Good. Now calculate for the purple one. Okay, what have we written is absolute blunder. Y B and supposed to be an R. Now the next thing is, okay, let's keep it as B1. Let's not mess it up. Keep it as B1. Okay. About B2? B2 is what? Next time you see it, you should be able to directly do it. You need to use that negative sign. I'll come to that point as well. 4 pi r into that of sine 0 again, right? It's again sine 0. Here also same 0 only, theta 1. Theta 2 is how much? It's like 45 degrees. Right? Think about this wire. First angle is 0, but second angle is 45 degrees. Easy, simple. Calculate them both. But here is the most important thing. Whatever you are calculating, net field, this is basically negative because this does not exist. This magnitude you have to subtract. So your actual B due to AB, or the field due to AB wire, is going to be how much? Your field due to AB wire is how much? B1 minus B2. Okay, that's it. End of the story. It's a very simple story. And I hope you understood this expression, because we have another straight wire to deal with. We will be directly using the next. And this is going to be 0 plus 1, basically 1. And on the like the negative one that we are calculating, how much is it? This is going to be 0 plus 1 by root 2. Over. And but do not forget the negative sign. So let's write down U to AB first of all. Okay. I think done wrong things here. This is not it. This is because this does not make sense. Right? This is wrong. So this should have been something like D, I guess, and this is the B. So don't worry about it. You know this thing. Okay, AB, and you have BC. Where does the tangent lie? N and D. D. This is going to be something. Anyway, now let's call this as 1. First, let's write down field due to 1. Very easy. Trust me, it's damn easy. Field due to 1. Okay. Just ignore this part. We can later on just write down what it is all. This should be N, this should be D, this should have been M. My mistake again. This should have been M. Okay, let's not focus on this. Let's focus on the real stuff that we need to understand. This is not at all important. Okay. B due to 1 is how much? Going to be like mu naught by 4 pi into I divided by R, which is the perpendicular distance, okay, into that of 1 minus, I'm just having a look at your chart, 1 minus 1 by root 2. Clear? Negative sign. Basically what have we done? We have just done this. We have done this. We took this value, we substituted this root 2, but added a negative sign, and we have 1. So whenever you see one such thing, you know you should be doing a negative sign, because you are going to subtract that magnitude. When I don't think about how much marks give your best efforts, this is not the time to think about it, right? Later on, you can think about how much mark you should be getting, etc. Okay, that is my suggestion now. Okay. So now again we have a straight wire situation here, right? And let's consider this to be part 2. Focus on your weightage, like your syllabus weightage. How much mark will I be getting in future? How does it matter? Here this should be like 45 degrees. Okay. And this should be how much? 90. It's infinitely long wire. Okay. Now, what about field at 2 due to that second? That's again a wire, right? How much is that? Okay. Mu naught by 4 pi I by R into that of 1 by root 2. Okay, let's going to be what? You know the thing, sine theta 1 plus sine theta 2. Sine theta 1 is how much? Sine of 45 degrees. This time this magnitude is adding up, so don't subtract it. Plus of sine of 90 degrees, the other one. Okay, that's it. So what do we have? Mu naught by 4 pi into I by R into that of 1 by root 2 plus of 1. Okay, now you know this thing. But we are missing something. What is that? So that is why I gave you that full explanation that this negative is a different thing. It's not due to direction, etc. You can assume it with direction. First, now we need to work on something known as direction. Okay, focus on this. First of all, let's talk about BC. Okay, BC wire is carrying current like this. That means the field is supposed to be at this. Let's call this as, you know, like O. At O, the field is supposed to be inwards or outwards? Outwards, right? Outwards. Is that it? You keep your thumb along the direction of current. How do you get it out? Good. Okay. Next. You know, it is how much? It is like outwards. Next. Let's focus on our first element. Our first element, how it is? Think about it. Like this. Current is like this. AB. This should be in which direction? This should be in inverse direction. X cross. Now you give either one of the negative sign and you work around the value depending upon however it comes up. Okay. Generally, I think we take outside to be positive because it is positive X, inside to be negative. Okay. Now we have one more thing in this thing. Forget this. Let me re-label it. It does not matter. This is N. This is D. You understood this part. Okay. Now current is like this. What is this? This is basically a circular loop. Right. First of all, this time let's do a thing. Let's discuss the direction. How is it? First of all, just a moment. Okay. Current direction is like this. The loop, it's like this, right? Current is flowing like this. Current is flowing like this. You're going to put it like this. How is it going to be outside? So let me call this like third part. Direction, outwards, inwards. Outwards, not inwards. Okay, outwards. So it's going to be a dot. Okay. Then what do we have? We have field due to this third component, which is going to be how much? Mu naught by 4 pi into I divided by r. In this case, you clearly know these things, I guess. If not, just try to grasp it right away, right now. Very important. Once we are done with this, right, you will be able to solve like almost any kind of this. I can call it to be like a little complex problem in terms of like the geometry. Into theta, is that it? In this case, theta is how much? 2 pi. Just reminding you. If not, you will be using some theta. It can also be an arc. Two different arcs in two different directions, carrying current in two different directions. Then you would be using it accordingly. All right, now we are done, students. So you can assign, kind of I by r into 2 pi. So now this is in outward direction. You have the third component to be having mu naught by 2 into I by r, and what it is going to be out. Add 1, 2, 3, end of the story. But with the sign, you should be careful about the sign. That's all you should be careful about. End of the story. That's it. Okay, forget all these labels that is present on the side. So total field, let's keep it in the outside direction. B1, okay, due to the AB element, then we have B2 due to this BC element, and then we have this third ring. Okay, blue colors all are outside. Okay, so substitute the sign accordingly because it is very important to get the answer. Okay, none other than that. So what do we have? B1 to be mu naught by 4 pi into I divided by r into that of 1 minus of 1 by root 2, subtracting the magnitude, and keep this as negative because that is why we are saying that is how you are supposed to do it, to find out the net magnetic field. And of course, in the direction of outside, it's going to be maximum. There are two things in that direction, right? So outside, as we are taking even the sign wise, it's positive. Okay. And then what do we have? Due to 2, you have something like mu naught by 4 pi into I by r into how much? 1 plus 1 by root 2. Then what do we have? Plus of mu naught by 2 into I by r. Okay, this is different. This is not I. This is part 1, part 2, part 3. I mean, like 1 part, 2 part, 3. Okay. End of the story, students. You add it up, you will get the answer. But anyway, let's do the calculation part as well. It's not a big deal. We'll be taking out everything common. Very simple ways of doing them. First of all, if you are noticing it carefully, this one, which is going to be minus 1 due to this minus sign, and this one would get cancelled. Okay, that's it. So let's do a thing. In the final result, we will take out mu naught into I by 4 pi r as common. Okay, then what does the first term yield? Minus of minus plus 1 by root 2. Okay, and this one is going to be also plus 1 by root 2. So basically 2 root 2. 2 divided by root 2, basically root 2. And here what do we get? 2 pi. Don't forget that we just add 2 pi. We could turn it that way. End of this 2. We can further simplify it and write it down. But you have to understand that thing, like how to solve. Okay, it's all in by 2 pi r. If you are noticing it, it's 2 pi r, 2 pi r. Of course, this is not the answer. Here we have a negative sign. This is not the answer. This is not the answer. But we need to all write it down in terms of mu naught by 2 pi r. If we are going to do that, we are going to get this as mu naught I by 2 pi r into that of pi. Another 2 gets cancelled out. We have 1 less. Easy, damn easy, simple problem. Okay, so only current carrying part is going to have any like magnetic field. That is the key part of this question. Other is assessing how to calculate for the first case, the first part. If you have understood that, almost you are done. Then comes direction. Okay, I hope this explanation was clear. Now let's get into another question. Let's do the another question tomorrow. Then we'll be having a session tomorrow at 7:30 again, but otherwise this question, let's quickly see if there is a shortcut for this. A long straight wire of radius A carries. Okay, we need some time for this. This is basically about your Ampere's law. So we'll be getting started. It's all to 2019 question. It's not 2020 question. It's not 2020 question. Even the earlier one was not 2020 question. So we already gotten into 2019 PYQs. So we'll do it tomorrow. This is a very interesting concept. It's going to be super interesting. So don't miss it out. There's something really, try it out. It's a very, very interesting one. And you'll love it. We'll get started with something known as Ampere's law. There was no Ampere's law based question in the last session. So we'll get started with an Ampere's law based question in the next session onwards. And we'll be also soon completing your 2019 question. So stay tuned. Many interesting questions are coming up. And students, this Friday from 10 a.m. to 1 p.m. we'll be having current and electricity part 4 PYQ discussion. And students, yes, this is one of the most important topic for your JEE preparation. Don't miss it out. You'll get 3 questions. So where it is going to happen? It is going to happen on your Unacademy learning app. 10 a.m. to 1 p.m. Do not miss out this interesting lecture on this coming Friday. And that being said, we have already completed electrical measuring instruments in one shot in a free special class of just 4 hours. So 1 4-hour session, you can complete your electrical measuring instruments. And what is this electrical measuring instruments all about? It's a very easy topic, and this also on Unacademy learning app, right? And what is this topic all about? It's a very easy topic from which you may get one among the 3 questions in your current electricity. You may not, you definitely get nowadays. So what kind of problems are being asked? Everything has been covered. Every single concept has been covered. Galvanometer working. How does that coil all works? The torque based problem, and how to like leverage galvanometer to make an ammeter or voltmeter, and how to like why not voltmeter, why potentiometer, like what are the applications of potentiometer, and how to use a meter bridge, and like what kind of applications do we have, like all the 3 applications: measuring EMF, measuring internal resistance, comparing EMFs. And not only that, like there's something known as end correction problem in your meter bridge. That also has been discussed. And definitely try and complete PYQs. There also we have many electrical measuring instruments question, because it's a very frequently, very easily asked, or like the most asked topic, you can say, or definitely asked topic, not even most asked, etc. It's a definitely asked topic. And we have discussed every single kind of problem in this one session, but you will get an like the feel of that problems from the PYQs, the kind of questions that are being asked. They are simple questions. So 4 hours, one simple question, or maybe even more than that in the current given situation, is what you can get from this single session. So try and complete it. It's available for free of cost on your Unacademy learning app as a special class. And that being said, do get onto our Telegram channel. If you are not yet present on our Telegram channel, do download a Telegram app from your Google Play Store and App Store. And the first search result, is going to be Telegram app. And then the first thing that you want to do is click onto this link, which is available in the description box below. And post that, you'll be getting onto a Telegram channel where you'll be getting live before time updates on every session conducted by our JEE English team, be it on Unacademy learning app or JEE English YouTube channel. You can also type in JEE_English to find us on Telegram. And students, yes, that post that you'll be getting onto our like awesome Telegram channels. And not only that, we keep you posted with the latest updates on everything on about your exam, etc., on your Telegram channel. And that being said, if you're looking for a complete package for your JEE Mains and JEE Advanced preparation, it's going to be Unacademy subscription in a day. Why do we say that? Because you can attend daily live interactive classes with the best educators across the nation. In fact, we have authors of your book like DC Pandey and DC Gupta sir on this platform, and you'll be attending these classes on a very interactive platform with polls and leaderboards. That way your learning becomes interesting, and you will also get access to lots and lots of test series set by the best educators, post which you'll be also getting analysis. Using this analysis, you can improve upon your overall performance. And not only that, you will also get access to lots and lots of live doubt clearing sessions on Unacademy subscription platform. And this is a very important and a major component of your preparation, and we provide this even in all of your courses in a structured manner. Every 4 session is going to be a dedicated live doubt clearing session, and in fact every course is going to be structured and well planned. You'll have doubt clearing sessions, quizzes, mega quizzes in each and every program on Unacademy subscription platform. And not only that, students, we have dedicated batches for 2021 aspirants, 2022 aspirants, and 2023 aspirants, being conducted by some of the best coaching institutes like Vibrant Educators, Bansal Class Educators, and some of our best team on Unacademy subscription platform. And you will get unlimited access throughout the period by availing Unacademy subscription. That is another beauty of Unacademy subscription. There are no batch restrictions. And that being said, once you go to the program selection, which should be the program that you should be going for. So let's say you are a 2021 aspirant with no plan for drop. You'll be going for a 6-month program, which is going to cost you near about 25,000. And if you are a 2021 aspirant with a plan to drop, or let's say you're a 2022 aspirant who has completed 30% of the syllabus, you'll be going for a 12-month subscription, which is going to cost you less than 35,000, 34,650. And let's say you are a 2023 aspirant, and we have started courses even for 2023 aspirant, and that is going to cost you only 50,400. That is about 25,000 a year. That is less than 70 rupees a day. So this is about a plus subscription. Right? This is an economical package, but we do also have something known as iconic subscription, where you don't only get access to all the features of plus, but you can also get access to one-on-one mentoring session, and personal coaching from IIT and NIT alumni who are educators on our platform. And so think about it, they have previously gone through this journey and they know the ups and downs of this journey. They will be guiding you with the necessary motivation that you need. They'll be conducting motivational sessions, and not only that, they will be also guiding you with the strategies that you need for successfully cracking the exam. And that all can happen on iconic subscription. And if you can afford it, it's good. If you can afford it, it's going to be an amazing thing for your JEE preparation. And a 6-month subscription is going to cost you 34,200. A 1-year subscription is going to cost you 58,500, and a 2-year subscription is going to cost you 90,000 for 2 years. That is going to be like 45,000 per year. Okay. And make sure you apply Murli Live code, be it you go for plus, iconic, 6 months, 12 months, or 24 month subscription, so that you get maximum discount on your subscription purchase. And you can also apply this on combo subscription. We have recently introduced something known as combo subscription. So what is this combo subscription? A combo subscription is nothing but a very economical package, a very economical complete package for your JEE Mains and CBSE board preparation at an economical cost, where you can attend the classes from anywhere with the best educators across the nation. And we do also have different combinations of this combo subscription. This includes iconic plus combination, full iconic combination, and also plus and plus combination. So plus of IIT JEE and plus of CBSE, and plus and iconic combination. And that being said, students, we are also available on iconic subscription. Our team, JEE English team, is also available on iconic subscription. You can take your JEE preparation to next level with our personal coaching, with our personal touch. We have a team of IITians and NITians and head of coaching institutes, and you can avail our expert guidelines as well. And students, do not forget to like and share this video. Do definitely share it on your social media like WhatsApp groups, Telegram channels, etc., because that is quite important, because it's a free of cost, full and high quality lecture for your JEE preparation. So do definitely like and share it on your social media, and also click on the bell notification to get timely updates. And that being said, do not forget to smile, keep smiling, and avoid any gossips. Ignore any gossips. Work hard and smart to achieve your success, and definitely do share it. And students, apply Murli Live code whenever and wherever necessary. You can in fact unlock many features avail upcoming Unacademy Combat on 31st January for free by applying Murli Live code. You need to just unlock them by applying Murli Live code. So for many features they'll be asking you for some code to unlock. You can make use of Murli Live code, and also like you can kind of avail your trial subscription with Murli Live code, and also you can get the best maximum discount by applying Murli Live code. And students, 7:30 p.m. tomorrow again we'll be having this magnetism PYQ discussion, and we are already got into 2019 PYQs, and 6 o'clock we are discussing gravitational PYQ. Okay, so yes, don't miss out the sessions. If you are missing it out, they are available as recorded sessions. Try and complete them.